Alright guys, today we're going to go through section 5.3 in your book. I'm going to do a couple examples from the book, give you guys some formulas and some background, and you'll probably have some time in class to work on the homework. For section 5.3, we're dealing with the trig functions. And so this is probably something that hopefully you're a little bit familiar with and should be a bit of review, but it's good to go over it. All of these trig functions, the ratios that we're using, only work with right triangles. For now, the only triangles that you'll see are right triangles, but eventually that won't be the case, and you'll need to be aware of when you can and can't use what we're learning today. Okay. Everything that we talk about today you'll only be able to do with right triangles, so you want to make sure that that's the case. This is the standard SOHCAHTOA deal. You can use SOHCAHTOA to help you remember what each of the trig functions is equal to. SOHCAHTOA helps you remember that the sine of theta is equal to the opposite over hypotenuse. The opposite is the side opposite the angle you're looking at, and the hypotenuse is always opposite the right angle. Cosine of theta then is the adjacent over the hypotenuse, and tangent of theta is the opposite over the adjacent. A couple trig functions that you might not be aware of is the cosecant, which is equal to 1 over sine theta, which would then be equal to the hypotenuse over the adjacent. Or the secant of theta is equal to 1 over the cosine of theta. So that would be equal to, this should be, sorry, the cosecant should be hypotenuse over opposite. The secant should be hypotenuse over adjacent. And then the cotangent of theta is equal to 1 over the tangent. And so that'll be equal to the adjacent over the opposite. Okay, those are the basic functions. The next thing that we're going to talk about is the unit circle. So I've got a unit circle right here. Basically what the unit circle tells you is the value of either sine or cosine based on the angle. This unit circle that I've got, and I've got this available for you at vast.ecollege.com to download and print out if you want. You can use it on your tests and quizzes. This unit circle lists the degrees and the radians for the angle measure. The first value listed in parentheses is the value of cosine. The second value listed in parentheses is the value of sine. So let's look at how this is useful to us. Let's try an example. Let's say we're trying to find the value of all of the trig functions for the angle 135 degrees. Okay, so let's start with sine. We want to find the sine of 135 degrees. So can actually just look at the unit circle here. 135 degrees is right here. It's 3 pi over 4, and it looks like sine is root 2 over 2, and cosine is negative root 2 over 2. So the sine was root 2 over 2. the cosine was negative, tangent is actually equal to sine divided by cosine. So you can find tangent by dividing the sine by cosine. So that's going to be root 2 divided by 2 divided by negative root 2 over 2. That's just going to be equal to negative 1. I can find cosecant of theta. Remember that cosecant is actually just 1 over the sine of 135. So this equals 1 divided by root 2 over 2, which I can simplify as 2 over root 2. And I should simplify it further so I don't have a radical in the bottom of that equation. I'm going to multiply the top and the bottom by root 2. It's going to give me 2 root 2 on top. And then on the bottom, root 2 times root 2 is root 2 squared, which is just 2. So this simplifies as just 2. I can do secant of 135. That'll be the same exact thing, except it'll be negative, so I can just skip all of that and say it's negative root 2. And cotangent, which is 1 over tangent. Since tangent was negative 1, cotangent is going to be negative 1. Okay. If you want to see more about this, you can look at example 3 in your book, which should help you out. Let's look at a different example now. This will be example 4 from your book. Let's look at another right triangle. Let's call this leg X, this leg Y, and the hypotenuse R. If we know that the hypotenuse is 10, we're actually going to be able to find the legs X and Y if we know theta. So let's say that theta is 35 degrees. I can set up the relationship that sine of theta is equal to the opposite over the hypotenuse, so that's y over r, or the sine of 35 degrees is equal to y over 10. If I solve this for y, I'll get that 10 sine 35 is equal to y, or y is equal to 5.74. I can do the same thing for cosine, except in this case it's adjacent, so that'll be x over r. I can solve that and have it be 10 cosine 35 is equal to x, or x is equal to 8.19. Okay, so those give me the two components of my hypotenuse, the x and y. If I wanted to go in the other direction, I could use those values to find the hypotenuse or to find the angle. Let's try that. So let's say that instead of being given the angle and the hypotenuse, I'm given the two legs, and I'm looking for the angle and for the hypotenuse. We can say that y is 5.74 and x is 8.19 like before, and so here we're just doing the exact opposite of the problem we just did. We can use Pythagorean's theorem to find the hypotenuse. That's just r squared equals x squared plus y squared, or c squared equals a squared plus b squared. Can solve this for r, and I'll get 8.19 squared plus 5.74 squared If you type that into your calculator, you'll find that equals very close to 10. And I can find theta by using the following equation, which is tangent, or the inverse tangent, also called the arctangent, of y over x is equal to theta. So I can plug that in. You can find this on your calculator by pressing shift or second and then the tangent button. The y value is 5.74, x was 8.19, and if I plug that into the calculator, I'm going to get 35 degrees. So you can see that using this method, we got back the same values we started with. Let's do one more example. Let's say that I'm told that the value of cosine theta is equal to negative 12 over 13. And I'm told that the angle theta, which I'm looking for, is in quadrant 2. Quadrant 2 in the coordinate system is over here, so we know the angle is there. If I were to graph this out, cosine is going to be the adjacent over the hypotenuse. So I know that I have a hypotenuse of 13. I know that this thing is in quadrant 2, so I can draw a line of length 13 in quadrant 2. I also know that the adjacent to this angle, so let's call it this angle theta here, we know that the adjacent to that angle is negative 12. Okay. I can complete the triangle again by using Pythagorean's theorem. R is equal to the square root of x squared plus y squared. I already have R, it's 13. I have x, it's negative 12. And I need to solve for y, so I'm going to square both sides, get 13 squared equals 144 plus y squared. Subtract this and I'll get 169 minus 144 equals y squared, and that's 25 equals y squared. So y is equal to 5, so the missing side here is 5. And now I can find all of the other values. Sine of theta is equal to the opposite over the hypotenuse, so that'll be equal to 5 over 13. Tangent's equal to the opposite over the adjacent, so the tangent of theta is going to be equal to 5 over negative 12. Okay, so that's another example of a problem that you might have on the homework. Your homework today is on page 296, and it's 14 through 19 all, and 38 through 44 all. If you guys have any questions, I'll be here after school in the lower school science lab, so come and find me, and I'll try to help you out.